I'm very happy and excited to be here moderating this panel. For those of you who do not know me, my name is Morane Gruenpeter. I lead open science operation at Software Heritage, and I actually arrived to Software Heritage as an intern in 2017. Yes. I didn't expect that. And it's a pleasure to be here presenting this panel. So from the furthest away, we have Kaz. Kaz Yamaji is a professor and director at the Research Center for Open Science and Data Platform at the National Institute of Informatics, DATAIA, in Japan. He earned his PhD in Systems and Information Engineering from Toyohashi University of Technology. His work is focused on modeling and developing a trusted e-science space to facilitate the sharing and reuse of research materials. Thank you, Kaz, for coming from so far. Next, we have Lorena Barba, further down the desk, coming from the United States. She is a professor of mechanical and aerospace engineering and international affairs at George Washington University, where she also directs the Open Source Program Office. Her expertise spans computational fluid dynamics, computational biophysics, and high-performance computing. In the open source software community, she is well known for her leadership as a member of the board of directors of NumFocus. Lorena was a founding editor of the Journal of Open Source Software and is now the editor-in-chief of the Journal of Open Source Education. Next, from Geneva. We are coming closer by. We are now in Europe. We have Micha Moskovic, which is a key member of the open science team at CERN, serving as the product manager for Inspire. He oversees the main information platform for high-energy physics research. Micha also contributes to the CERN Open Source Program Office, emphasizing the open science aspects of open source and monitoring efforts. Next, we have Nicolas. Nicolas Fressengeas is a professor at Université de Lorena, where he also serves as the vice rector in charge of digital, data, and open science policies. After earning his PhD in physics, his research shifted towards the design and optimization of materials for optical applications. Nicolas has played a crucial role in shaping open science policies at both his university and nationally for France. Next, we have Sarah Cohen Boulakia, coming from Université Paris-Saclay, full professor and deputy director of the DATAIA, the University Artificial Intelligence Institute. She leads the bioinformatics group at the Laboratoire Interdisciplinaire des Sciences du Numérique and focuses on computational reproducibility, data provenance, and the integration of biological databases. And last but not least, we have Ezra Clark from this building, so the closest by, maybe an elevator ride but he is the chief of section for science, technology, and innovation policy here at UNESCO. Prior to this, Ezra worked for the United Nations Environment Program in the field of ozone and climate under the Montreal Protocol. Ezra holds a PhD in freshwater ecology and hydrology from Exeter University, the United Kingdom. And before I go to the questions for the panelists, I'm going to ask you, the audience, a question. Who here is familiar with the open science vision? Just familiar. I would like to have a full room, but I don't know. Maybe you're not familiar with open science. So yes, thank you very much. Now, keep your hand raised. Yes, well, wait for the question. Keep your hand raised only if you are actively engaged in making this open science vision a reality. Okay, okay. Oh, I'm impressed. I didn't expect that so many hands will be raised. Yes. Yes, you can keep them raised because Benoit is taking a picture. But we will move to our panelists, and we will start with the same order with the first question that I have for each of and everyone, which is, please share with us your activity in the open science landscape and why open source software is important for open science. We will start with Kaz. Thank you.
Okay. My research center has a mission to provide a data platform, so-called NII Research Data Cloud, to the whole entire Japanese university and research center. And in order to provide our software infrastructure, the main mission or the voice to the users is to support the reproducibility and the reusability of the research outcome. So which means that, of course, the data is important, but in addition to that, the software is, of course, so important to reuse and to reproduce the research outcome. So that's the main connection between my service and the software, in shortly.
Thank you, Kaz. Next, we have Lorena.
Thank you, and thank you for the kind introduction. My role in open science as a sector, right now I am the faculty director of the Open Source Program Office at my university. This is a new effort funded generously by the Sloan Foundation. And we view in the context of the university that an open source program office might extend its scope beyond software to all aspects of openness, including open access and open data and open education, or at least help support those missions as well. Previous to that, I have been involved in open source software for a long time as the journal editor for the Journal of Open Source Software, and have been involved in reproducibility for a long time as well. Was a member of the US National Academy of Science study group on reproducibility and replicability in science. And going way back until from my early days as a researcher, and something that I published as called the Reproducibility PI Manifesto, a pledge to work reproducibly. And what is the importance of open source in open science is the question. We all, of course, understand that open source software provides transparency in research, in making the software able to be inspected by other researchers to trace the computations that lead to the result or findings. And we also understand that it enables proper licensing for reuse. We may also understand that it improves quality of the software because many more eyes are able to see it and contribute to its development. But sometimes we forget other things that are involved with open source software, which are my main point for today. Open source software builds trust through its open processes, and it's something that I believe can be translated to other areas of our endeavors. We can learn from the way that open source developers interact with each other to build trust in their joint projects. Open source creates collaborative networks that allow for this open sharing. So my main point today, my only point today, is that it's not just a technical problem. It's not just about the artifact, the code, but part of the heritage of software, open source software, is also its culture and the way that it supports core scientific values. So just like in this building, there's some invisible architecture. If you saw in the tour, there is also some invisible cultural heritage in open source software, which is through the ways that developers collaborate in open models.
Thank you, Lorena. Next we have Micha.
Yes. So CERN has a very long history with open science, dating all the way back maybe to the establishment of CERN with the CERN Convention in 1954 that I want to mention because it was signed here at UNESCO. And the convention states that all the research of CERN should be available for the public. And then in more recent years, we have a more organized way to do open science through our policy, open science policy, which organizes open science through 9 different open science elements, ranging from more traditional aspects like open access to publications, where we reach something like 96% of open access publications in the field. And then going to things like open data, where all the results of the CERN experiments eventually will be, all the data of the results will be published as open data sets, but also open source software, open source hardware, open research infrastructures, and others that I won't mention here. And the importance of open source software for open science, at least from my point of view, is that in fields that are very data intensive, that produce lots of data, like for example at CERN, where experiments produce petabytes of data, to connect this data that is the result of the experiment to the eventual publication that is the structured outcome, you need software. And so the software is an essential part of the research process.
Thank you, Micha. Next, we have Nicolas.
Thank you, Morane, and thank you for really the invitation. It's an honor to speak here. So I will speak from Lorena as the vice rector of the University for Open Science and Digital Policy. My job there is to foster open science in the line of the French National Plan, at least for the 3 axes of the French National Plan, means open access, sharing of data, and of course open source. So what are the main actions to that is well, there are 3 main actions. The first one is to make the opening of science feasible, doable for the researchers. The other one is to make it easy. And finally, so that they do it, to make it rewarding. To speak only about the open source part of this open science policy, to make it possible, we need infrastructures, and fortunately, mainly most of the infrastructures are there. So, what are the infrastructures we rely on? We have a in-house GitLab Forge, which still have to build fully, and we rely, of course, on software heritage, and which is particularly valuable, its link with HAL. So the link with HAL and software heritage allows us to open the software in terms of infrastructures. Then we have to make it easy. To make it easy, we have to train people, and that's not so easy to train people to do open source, because we have a community who knows open source very well, and another community which does not at all. So what we did, and that's not brand news because it's not yet public, but we had an ambassador, a network of data ambassadors in the university, which is quite large, 60 units of research, and we have changed to open science ambassadors, and this open science ambassador can pick a badge or several badges, and where there will be trainers on open access, or on open data, or sharing of data, or on open source code, and they will they can have several badges. This will be public, so it'll be rewarding for them. And the fact is that these people are researchers. They are researchers, so we are a multi-disciplinary university, though the researchers are in the different disciplines of the university. At least that's the goal. And finally, we have to make it rewarding. So it's some work, to do open source code, to learn what is open source code, and to do and really do it properly. So you have to make it rewarding. And today, probably the way we evaluate research is not so rewarding for these kind of activities. So we are engaged in COARA, the Coalition for Advancing Research Assessment. So I don't know if you know about it, but that's a European, at the start, a European initiative, which is now international, and which is signed by 800 institutions, among which, of course, my university. Though we aim to promote and reward all the products of research, among them, of course, open source code. And the question is, why is open source code so important in open science? And my favorite, figure for illustrating that is the one I always see in the slides by Roberto, is the triangle of trust. When you publish something, when you publish some data, some work, research work, you have the paper, of course, in an open access repository, and you have the data. But if you have only the paper and the data and you don't have the software that uses the data to produce the paper, the picture is not complete. So the triangle of trust is paper, data, software. And this is why software source code is really, really important. Thank you.
Thank you, Nicolas. I hear the word trust is spread around, so maybe we'll come back to this later on in the questions. Last but not least, we have Ezra. Ezra, go ahead. Thank you.
Thank you very much. Thank you. Yeah, it was good to see how many hands went up, and I hope this knowledge and experience in open science extends to the knowledge of the UNESCO recommendation. So here in UNESCO, our focus is on setting global standards and norms for open science. And in this context, we've developed the first international standard setting instrument for open science, the UNESCO recommendation on open science in 2021, which was adopted by our 194 member states. And this provides the first internationally agreed definition of open science and a common set of values and principles for its implementation. Following on from this, we've been carrying out with our member states and various other stakeholders a series of activities on implementation, including a steering committee, working groups of some 1,000 members at the moment, and developing specific products and tools to provide assistance to specific groups and stakeholders on various elements of open science, which we call the Open Science Toolkit. All of these are, of course, available on the website. And I guess the core effort is building an open science culture by assisting principally our primary target, I guess, member states, but many other stakeholders, to adopt the policies that support open access to research, publications and open data repositories, and of course connected to that, the open source software. Just to mention, the first monitoring of the implementation of this recommendation will happen this year. It's ongoing, and this is a requirement of such recommendations in UNESCO. And this is a very important exercise for us because it really is an exercise in gathering information on the progress countries are making in open science. And so far, we're early on in the stages in processing the data, but there's some quite exciting progress we can see in countries. And specifically related to the open source software, we see this really as a key component, a key element. Some of the pillars in the opening were mentioned, the pillars of this UNESCO recommendation, and the open source software is certainly there as a key element in this pillar of open science knowledge. And we consider that, along with open access to publications and data, a core element. And as you mentioned, the importance of it being in a triangle, so hugely important. And the open source tools can provide cost-effective access to cutting-edge research methodologies and enhance collaboration between researchers and policymakers. And if I will, and it's not looking too much like an advert for the recommendation, I'll just read just very briefly from here. So this is in the section on open science software in the UNESCO recommendation on open science. In the context of open science, when open source code is a component of research processes, enabling reuse and replication generally requires that it be accompanied with open data and open specifications of the environment required to compile and run it. So to ensure the reuse, replication, transparency, and the research process. Artificial intelligence, of course, poses some specific challenges, which I don't think we'll get into. But just to highlight, the open source software also providing a bridge for societal engagement, particularly when we talk of citizen science and the requirement on low-cost hardware and software, not having access perhaps to sophisticated and expensive equipment. And also UNESCO advocating for funding mechanisms that include earmarked support for open science software development as part of the process. So really, let's say the open science software embodies the principles and openness and collaboration that underpin the open science, and particularly, I would say, from our view, the open science recommendation.
Thank you, Ezra. And I don't know if you saw that in the audience, but I've skipped a panelist. Are you awake? And did you notice that? I'm sorry about it. And I'm going to come back to Sarah and give her a little bit more time and maybe a question just afterwards. So go ahead, Sarah. Go.
Thank you very much. So I try to be very quick. So I belong to the bioinformatics community where actually we have sharing in our DNA. So in a sense, we share data sets naturally, we share software, we share workflows, analysis pipeline. So open science is everywhere for us. I also belong to the computer science community, to the provenance and reproducibility topics. And I would say that part of my activity relies on running with a lot of colleagues, the French Reproducible Network. So several members are on the room. I would like you to raise your hand so that we can see I would say 15 people, probably. So the idea of this network is to try to organize training, events, and we are happy to say that we are now supported by the French Ministry of Higher Education and Research as a network. And we would be very happy to see you in Lyon at the beginning of April. And I will finish with that. Thank you.
Thank you, Sarah. It's nice to see there's a lot of reproducible research network people in the room, and I will take that as my next question directly to you, because you're ending the panel normally. Yes. So my question for you about reproducibility and its challenges when it comes to software, how would you say that software identification can impact that?
So we've seen actually excellent talk before, and especially this morning too, on the problems of, in a sense, being able to identify a software. We have common names. We have a lot of different ways of identifying a software within the code, but also in papers and all the documentation and things like that. When it comes to reproducibility, in a sense, we have two ways of doing it. Either we have a complete white box, we are in open science, we can open the box and see the code and try to understand it, because it's not because you have the code that you understand what it's going to happen. But in some of the cases, we have, let's say, black boxes or gray boxes. And this is where knowing as precisely as possible what we mean by software is completely, to me, an open research topic where we should put found and brain effort, let's say.
Thank you, Sarah. With that, I'm going to move to Lorena about trust. How would you, because I'm going to ask a question that I didn't plan, but we'll see how that goes. How would you build trust in this space, in the open science space?
Thank you, Morane, for that opening. Well, I think open source software is an opportunity. Oftentimes when we talk about reproducibility, one might say, well, why do you need to actually make the software open source? I mean, if I can see it, I can inspect it, why do we need an open source license attached to it, providing reuse? And here again, I touch back to the idea that open source is not just about the license, it's also about a development model, a way of collaborating. And so open source is an opportunity because it enables these rich networks of connections between the artifacts that you're creating together in usually distributed teams, and the ways of coordinating that team to provide, using established open source practices to provide trust overall on the product. And so in science, the reason we care about reproducibility is not for reproducibility in itself, but because reproducibility also is a way of ensuring trust. And so in a way, open source software provides this opportunity to achieve the trust that we're trying to build on our scientific findings, with also a whole culture that has developed over the years for governance and how to coordinate our work together.
Thank you, Lorena. I'm going to take this theme of trust and building trust to our infrastructure representatives. So I'm going to ask the same or a similar question to you, Kaz. How infrastructure can enable trust and get the users to trust the infrastructure?
So if I would say the trust for the research outcome, so maybe based on the software, so maybe the infrastructure can connect the researcher between the software provider and the software consumer. So the infrastructure or service have to be the glue between the two. And in our case, as I said to you before, I'm building and developing the NI Research Data Cloud, which composed by three main components: RDM, publication, and discovery. And in our RDM platform can easily initiate a Jupyter environment and the back and forth the data and the source code between the two. And once the researcher get the result, they can pack the source code and the data and the publicize from our repository system. And the successor, the following researcher can easily get such a the package and reproduce the same result by using the easily initiate, just clicking the one button and just easily initiate and reproduce the environment. And this is the things we are trying to say about the trust by using our the software, by using our the research environment. And maybe I know the software heritage, and of course in this the country HAL has a tight coupling integration between the two, but this has to be beyond much more early stage of the research process. That makes the researchers and brings the researcher more trustworthy.
Absolutely. Thank you very much, Kaz. I'm going to continue with the same question for you, Micha. Go ahead.
Yeah, I agree with my neighbors that making things open, it allows trust because people can inspect it. They can see how it works. They can look at the data. They can see how the sausage is made, so to speak. And that allows to build a great amount of trust.
Excellent. I hear a lot of transparency in this panel as well. I will move down to the table towards Nicolas and Ezra, maybe ending with one question, maybe a bit different from what because the question I wanted to ask is about challenges, but maybe let's discuss open science culture with a brief sentence. What is the challenge and how can we solve it? I'm going to start with you, Nicolas.
So in the open science culture, indeed the problem is we are facing a culture change. We're facing a culture change. So there's one challenge, and I will go a little bit back to the question that was prepared indeed, because you're talking about challenge. I will be very fast on that. We have seen from a slide from Roberto, which is also confirmed by a recent study here in France, that 50% of the open source software come from computer science, physics, and math. That means that there are other 50% that coming from elsewhere. And so they come from other disciplines, many other disciplines. But my feeling in the university, my experience in my university and in my discipline, which is physics, but physics down the line, close to engineering, says that probably this 50% figure is really, really underestimated, because we have people in physics, we have people in biology, we have people in chemistry, we have many people in humanities doing software, producing software. They don't even know they're doing that. So the problem is, so they make them understand they are doing software, they should be sharing this software, they should be using and sharing open source software, because this is a matter of trust in their research. And this is my opinion, that is the greatest challenge of all, is looking at the elephant in the room we don't see.
Thank you, Nicolas. Next you go, Ezra, and this will be the last remark before the final conclusion. Go ahead, Ezra.
Thank you very much. Well, to consider a change in culture or development of a culture would need kind of improvement in trust, in knowledge, and in an understanding. And to do that, for us, and something, as I mentioned, we're working on is really to ensure that open science and as open source as a important component, element of that, is to ensure that there's clear and shared understanding of what open science is and what its components are. And it was mentioned again in the opening, the pillars under the recommendation of open scientific knowledge, open science infrastructures, communication, open engagement of societal actors, and dialogue with knowledge systems. And in terms of the open science knowledge, we very much include in the software in that, but not to take this out, but to consider really the open science infrastructures as a key component and element of the open science ecosystem as a whole, and really to rely on the continuing to build trust and build knowledge in that, to have an understanding. And I think that would help to build this kind of culture of open science. It really does require a change in culture and approach. Thank you.
Thank you very much. I will let the panel conclude. So you have one sentence each, but really like 30 seconds. I don't want to hear another word, okay? I'm going to start with you, Ezra, because we're going to do the table thing. Ezra, Nicolas, then we move forward, okay? Go, Ezra.
There wasn't a question.
The question is a conclusion, like a takeaway, a conclusion for the panel, the last message. But if you want, you can skip
my conclusion is, it was really encouraging to see the amount of people here in this room that have an understanding and appreciation of open science. We all need to make an effort to share this and to develop more and more to have this change in culture. So people, before they reject or dismiss or don't appreciate, to understand genuinely what it is and what the elements are. And that will help develop this culture and progress open science, specifically helping us in terms of open source data.
Thank you very much. Nicolas.
I will build on what you just said, Morane. We heard a lot of times the word trust. So if we want to have more trustworthy research, we need to have more reproducible research, and open source software is one key component of trust in research, and therefore software heritage is.
Thank you, Nicolas. Next, Lorena.
Thank you. To highlight the importance of open science, I want to remind you all of one example, which is after the discovery of the coronavirus disease in 2019, this molecular structure of the virus was published immediately by the Chinese researchers. And this unchained a fast sequence of findings and publications, and journals opened, their chemistry journals opened their all of their related research to be read outside the paywall. And this led to the development of a vaccine in record times. And having shown that science can advance that rapidly with openness, then why go back?
Thank you, Lorena. Yes, why go back? Go, Sarah.
So I would say that science is cumulative by essence. New results are always built on top of previous results. And without transparency in software, there is no reproducibility, no cumulative science, and thus then no trust in science.
Thank you, Sarah. Next, Micha.
Yes. So, well, open science often is considered as various disjointed practices and research outputs. One thing I want to emphasize is it's really bigger than the sum of its parts. And software heritage is a great example of that. It's an open research infrastructure built on open source for the preservation of open source. And it comes with a great open data set that enables new research practices and allows to address new questions that will then create new open data, new open source software, and new open access publications.
Perfect, thank you. Next, Kaz.
More practical. Since I'm here, maybe my mission takeaway is to connect the infrastructure between the two countries, Japan and French, and especially focusing on software heritage to make Japanese researcher more trustworthy.
Thank you, Kaz. And with that applause, please, for the panel. Thank you.